As you're all aware, some objects look bigger and some objects look smaller. That is a function of how large of an area of the retina the light from that object falls upon. And that in turn is a function of what's called the apparent angle, kind of the angular span that it subtends in your field of view. So for instance, here's an observer, and there's some objects. For the larger object there, the line of sight from the observer's eye to the top and bottom of the object form an angle, and that angle right there is going to determine how large the object looks. How large things appear depends on kind of two major variables. First of all, how large it is. Everything else being equal, a large object is going to look bigger than a small object just because it's a much smaller angle. For instance, here's four objects that are different sizes. They even have their dimensions written on them. They're all the same distance away, and the large one looks the largest, and the little 2 by 2 inch square looks the smallest. Another variable, though, is the distance, how far away the object is. The same object will look very, very large up close, but then as it gets farther and farther away, it forms smaller and smaller apparent angles and lands on smaller and smaller portions of your retina and just looks like a smaller thing. Here's three objects that are all the same size. The one in the middle has some extra lines on it, but they're still all the same size. If I take the one on the right, though, and move it back, it gradually gets smaller in appearance. And moved back to twice as far, it looks half as big. Notice it looks half as tall and also half as wide, so the area is really a fourth of the original. If the other one is moved even farther back, about 4 times farther away, it looks to be about 1/4 as big. Again, 1/4 as tall and 1/4 as wide, so just 1/16 of the cross-sectional area. This is a common effect that you've seen many occurrences of. Now here's 4 objects that look very similar in size, at least apparent size. Now they could be a mixture of larger things far away and smaller things close up. It's actually pretty hard to tell without any other clues or without the ability to move around. Can you guess? Looks like the one on the far left was pretty small and pretty close, and the next one over was the biggest and the farthest. And here's the same 4 objects just turned around so you can see the labels. And remember, the printing is all pretty much the same size on all 4 of them. Unfortunately, planets and stars don't come with actual size labels printed on them. With 2 variables in play, it's quite possible for a large object and a small object to appear the exact same size if their distances are also in just the right ratio. That's what occurs with the moon and the sun from the Earth's vantage point. the moon's much smaller, but also much closer. And they just happen to be in the same ratio so that they look very close to the same size. They're both right around 1/2 degree in angular width. But in reality, the moon's a lot closer and a lot smaller. In fact, it's a much more extreme difference than what's shown here. Here we have a large object, Seminary Hall, about 200 feet away. But I have a much smaller version of at least the middle of Seminary Hall. Only about 1/400th the size, about 1 inch tall is all, but about 400 times closer. It's just a few inches from the camera, whereas Seminary Hall is like 200 feet away. And right about there, they're about the same size. In fact, we could even eclipse Seminary Hall with the picture of Seminary Hall. So the sun is 400 times larger than the moon, but about 400 times farther away, so they appear about the same size in the sky. If you could actually bring them together side by side, they would compare more like this little Seminary Hall compared to the real Seminary Hall.